vectors, vector u and vector v, are such that magnitude of vector u is 3 centimeters and magnitude of vector v is 10 centimeters. And then vector u plus vector v, magnitude of vector u plus vector v equals root 139. Find I, the angle between vector u and vector v, and II, the scalar dot product of vector u and vector v. So using cosine rule, we know that the magnitude of vector u plus vector v squared is equal to magnitude of vector u squared plus magnitude of vector v squared, then plus 2 times magnitude of vector u times magnitude of vector v cos theta. So the question says magnitude of vector u plus vector v is square root of 139. So this implies that square root of 139 squared equals magnitude of vector u, which is 3 centimeters. So it is 3 squared plus magnitude of vector v, 10 squared, plus 2 times 3 times 10 cos theta. So root 139 squared is 139 equals to 3 squared is 9 plus 10 squared is 100. Then plus 3 times 30 is 3 times 10 is 30 times 2 is 60. So this becomes plus 60 cos theta. So 139 is equal to 9 plus 100 is 109 plus 60 cos theta. So 60 cos theta is equal to 139 minus 109. And 60 cos theta is equal to 139 minus 109 is 30. So we divide 2 by 60, divide here 2 by 60, so that this 60 and 60 cancels out. So cos theta is equal to 30 divided by 60 is 1 over 2. Therefore, theta is equal to cos inverse of 1 over 2. And theta is equal to 60 degrees. So the second part of the question says we should find the scalar dot product, u and v. So the dot product between u and then v is equal to magnitude of the vector u times magnitude of vector v cos theta. Magnitude of vector u is 3. Times magnitude of vector v is 10 cos the angle. The angle is what we just found, 60 degrees. So it's cos 60. This is equal to 30 cos 60. And this is 30. Cos 60 is 1 over 2. So 30 times 1 over 2. And this is equal to 30. This is equal to 30 times 1 over 2 is 15. So therefore, the dot product between vector u and vector v is 15. Using the scalar dot product, find correct to the nearest degree the angle between vectors A, which is equal to 3i plus j, and vector B, which is equal to 8i plus 9j. So vector A equals 3i plus j, and then vector B equals 8i plus 9j. So vector A dot vector B equals magnitude of vector A times magnitude of vector B, then cos theta, where theta is the angle between A and B. So let's first find A dot B. This is equal to 3i plus j dot 8i plus 9j. This is equal to 3 times 8 plus 1 times 9. 3 times 8 is 24 plus 1 times 9 is 9. And 24 plus 9 is equal to 33. So having found this, let's find magnitude of vector A. So let's find magnitude of vector A. This is equal to square root of vector A is 3i plus j. So that is square root of 3 squared plus 1 squared. And this is equal to 3 squared is 9 plus 1 squared is 1. That will give us square root of 10. So let's find magnitude of vector B. Is equal to square root of vector B is 8i plus 9j, so which is a squared plus 9 squared. And this is equal to 8 squared is 64 plus 9 squared is 81. And that will give us 64 plus 81 is 145. So square root of 145. So we can then take this and then put it in the formula. So the dot product is 33. So remember, the formula is vector A dot vector B equals magnitude of vector A times magnitude of vector B cos theta. So vector A dot vector B is 33. So 33 is equal to magnitude of vector A is equal to root 10. Then times magnitude of vector B is equal to 1 root 145. Then cos theta. So this implies that cos theta is equal to 33 divided by root 10 times root 145. So cos theta is equal to 33 divided by root 10 times root 145 is equal to 0.8666. And therefore theta is equal to cos inverse of 0.8666. And therefore theta is equal to 29.93, which is approximately 30 degrees. Two ships, A and B, leave port simultaneously. A steams at 10 kilometers per hour on a bearing of 160 degrees, whilst B steams on a bearing of 215. After 1 hour, the bearing of B from A is 260 degrees. Find the speed of B correct to the nearest whole number. So let's assume that this, let's sketch it here. Let's sketch all of this information. So let's assume that this is the port P. The question says that A steams at 10 kilometers on the bearing of 160 degrees. You know, bearings are measured with reference to the positive y-axis. So 160 degrees will be, this first quadrant is 90 degrees. So if we add 60 degrees to 90, 70 degrees to 90, we will get 160. So we need to add 70 degrees to this 90 to get 160 degrees. So this is how A left the port. So this is the destination of A. Then he says that he left the port at with a speed of 10 kilometers per hour. Whilst B steams on a bearing of 215 degrees. So 215 degrees. What does this mean? This is 180 degrees. So if we add 35 to 180, we will get 215. So it means that B left the spot here, somewhere here. So we need to add, so this angle is 35 degrees. The angle over there is 35 degrees. Then he says that after 1 hour, the bearing of B from A is 260 degrees. So this is A. This is 180. So 260 means that we will add 80 degrees to 180. So if we add from here to here, from this place to this place is 180 degrees. So we need to add 80 degrees to 180 to get 260. So it means that this angle here is 80 degrees. So this is B. But please, this has not been drawn to scale. So that is the disclaimer. Now let's find the rest of the angles. But he didn't give the speed of B because we are supposed to find the speed of B correct to the nearest whole number. So let's use properties of angles to find this angle. This angle is very important because it will help us find the speed of B. So this is 80. It means that this is 10 degrees. And then you can see that this angle here, 70 degrees, alternates with this angle here. So this place too is 70 degrees. And this place is 35 degrees. So, and the whole of this quadrant is 90 degrees. So 90 minus 35 will give 55 degrees. So this portion is 55 degrees. So you can see that this 55 degrees alternates with all of this angle. So all of this place is 55 degrees. So since we know that all of this place is 55 degrees, can we find this angle? And you can see that this angle alternates with this angle, which is 10 degrees. So here is 10. This is also 10. Alternate angles are equal. So all of this is 55 degrees and this is 10 degrees. So we just have to subtract 10 from 55 to get the angle here. So it implies that the angle here is 45 degrees. This angle is 70 degrees. So it means that, and all of this quadrant is 90. So 90 minus 7 is 20. So the angle here is 20 degrees. So let me redraw this information well so that we can see it in the form of a triangle. So using port P. So this is P and this is A and this is B. So you can see that the angle which is here is 20 degrees plus 35 degrees, and that is 55 degrees. And the angle here is 70 degrees plus 10 degrees. So this part is 80 degrees. We could calculate this angle or just use sum of the total angles in a triangle. But then we've already determined that this angle is 45 degrees. So this is 45 degrees. And then here is 10 kilometers per hour. What we are looking for is the speed of B. and the speed of B is here, which is x. So how do we find x? You see that we can use sine rule. So sine 45, the angle facing this 10 kilometers is 45. So sine 45 degrees divided by 10 is equal to sine 80 degrees divided by the angle facing 80, which is the length facing, divided by the length facing 80, which is x. So let me come and continue at the top here. So it is sine 45 degrees divided by 10 equals sine 80 degrees divided by x. So let's make x the subject by cross multiplying. So x sine 45 degrees is equal to 10 sine 80 degrees. So x is equal to, if you divide through by sine 45, it's 10 sine 80 degrees divided by sine 45 degrees. X is equal to 10 sine 80 degrees is 9.848 divided by sine 45 is 0.707. Therefore, x is equal to 13.93. But the question says that we should find it correct to the nearest whole number. So the nearest whole number will be x equals 14 kilometers per hour. Given that the vectors, vector A equals ki plus 2j, and vector B equals 2i minus 4j, and vector C equals i minus 2j, find the value of k if vector A and vector B are perpendicular. AB is parallel to OC, where O is the origin, and then the B part, the unit vector along B minus C. So since vector A, so vector A is, let's write vector A. Vector A is equal to ki plus 2j, and vector B is equal to 2i minus 4j. And he says that A and B are perpendicular. Since vector A and vector B are perpendicular, it implies that vector A dot vector B is equal to 0. In other words, the dot product between vector A and vector B is 0. So let's find their dot product. So it's equal to ki plus 2j dot 2i minus 4j equals 0. So this is k dot 2 in one bracket, then plus 2 dot minus 4 is equal to 0. So k times 2 is 2k, then 2 times minus 4 is minus 8 is equal to 0. So 2k is equal to 8. Dividing through by 2, find out that k is equal to 4. So since k is 4, it implies that vector A is equal to 4i plus 2j. So the second part says we should find the value of k if vector AB is parallel to OC. So in other words, vector AB is parallel to vector OC, which is the position vector. Since they are parallel, it means that they have equal gradient. So let's first find vector AB. Vector AB is equal to position vector OB minus position vector OA. So position vector OB is 2 minus 4. So it is 2 minus 4 minus vector A, and vector A is K2. So this is equal to 2 minus K, and minus 4 minus 2 is minus 6. So this is vector AB. But it is parallel to OC, and then OC is I minus 2j. So OC is I minus 2j. Now, we've established that since they are parallel vectors, they have equal gradient. So what is the gradient of AB? MAB is equal to the y component divided by the x component. And the y component in this case is minus 6 divided by the x component, which is 2 minus k. So this is the gradient of vector AB. Now let's find the gradient of position vector OC. This is the y component, which is minus 2 divided by the x component, which is 1. This is equal to minus 2. So we can then say that gradient of AB, vector AB, equals a gradient of position vector OC. So this implies that minus 6 over 2 minus k is equal to minus 2. So let's multiply through by 2 minus k. So we multiply here by 2 minus k. Multiply here too by 2 minus k. So this part and this part cancel. So we have minus 2 times 2 minus k is equal to minus 6. So minus 2 times 2 is minus 4. Minus 2 times minus k is plus 2k equals minus 6. So 2k is equal to minus 6 plus 4. 2k is equal to minus 6 plus 4 is minus 2. And dividing through by 2, we find out that k is equal to minus 1. Then the last part is the unit vector along vector B minus C. Now, what is vector B minus C? Vector B minus C is the same as CB. So let's find the position vector B minus C. This is equal to position vector B is 2 minus 4. 2 minus 4 minus position vector C, which is 1 minus 2. So this is equal to 2 minus 1 is 1, and minus 4 minus minus 2 is minus 4 plus 2, which is minus 2. And therefore, position vector B minus position vector C is 1 minus 2. Let's find the magnitude of position vector B minus position vector C. This is equal to square root of 1 squared plus minus 2 squared. And this is equal to square root of 1 squared is 1 plus minus 2 squared is 4. This is equal to root 5. So the magnitude of position vector B minus position vector C is root 5. So we can find the unit vector B minus C. So unit vector of position vector B minus position vector C is equal to vector over magnitude. And the vector is I minus 2j divided by the magnitude, which is root 5. So this is the unit vector. And therefore we can rationalize by multiplying both the numerator and the denominator by root 5 over root 5. So that this is equal to root 5 over 5 times I minus 2j. The position vectors A and B are vector A equals 4i plus 9j and vector B equals 3i plus 5j. Find the scalars m and n such that ma plus nb equals 11i plus 9j. B, the magnitude of 2a plus 7b. And then C, the acute angle between vector A and vector B. So vector A is equal to 4i plus 7j, and vector B equals 3i plus 5j. Then the formula says that m times vector A plus n times vector B is equal to 11i plus 9j. So we need to multiply vector A by m, add it to multiply vector B by n, add and equate to 11i plus 9j. So vector A, so let me write it, m times vector A, which is 4, 7, plus n times vector B, which is 3, 5, is equal to 11, 9. M times 4 is 4m, and then m times 7 is 7m, then plus 3 times n is 3n, then 5 times n is 5n, equals 11, 9. This implies that 4n plus 3n is equal to 11, equation 1. And then 7m plus 5n equals 9, equation 2. So let's make m the subject from equation 1. So from equation 1, m is equal to 11 minus 3n. 11 minus 3n divided by 4. This is equation 3. So let's take equation 3 and insert it into equation 2. So we get 7 times 11 minus 3n divided by 4 plus 5n is equal to 9. So let's multiply through by 4. So it becomes 4 times 7 times 11 minus 3n divided by 4 plus 4 times 5n equals 4 times 9. So this 4 and this 4 can cancel, so that we'll get 11 times 11. So that we'll get 7 times 11 minus 3n plus 4 times 5n is 20n equals 4 times 9, which is 36. So 7 times 11 is 77 minus 7 times 3 is 21n plus 20n equals 36. So minus 21n plus 20n is minus n equals 36 minus 77. So minus n is equal to minus 41. So if we divide through by minus 1, we find out that n is equal to n is equal to 41. So since we know the value of n, let's insert the value of n into equation 3 to find m. So m is equal to 11 minus 3n divided by 4. So m is equal to 11 minus 3 times 41 divided by 4. M is equal to 11 minus 3 times 41, which is 123 divided by 4. So m is equal to 11 minus 123 is minus 112 divided by 4. So m is equal to minus 112 divided by 4 is minus 28. The second part of the question says we should find the magnitude of 2 times vector A plus 7 times vector B. So this is equal to, let's first find 2 times vector A plus 7 times vector B. So this is equal to 2 times vector A is 4i plus 7j, and plus 7 times vector B is 3i plus 5j. And this is equal to 2 times 4 is 8, 2 times 7 is 14, plus 3 times 7 is 21, and 7 times 5 is 35. And this is equal to 8 plus 21 is 29, and 14 plus 35 is 49. And therefore magnitude of 2a plus 7b is equal to square root of 29 squared plus 49 squared. This is equal to square root of 29 squared is 841. Then plus 49 squared is 2401. And this is equal to 56.9. The C part says we should find the angle between vector A and vector B. So vector A is giving us 4i plus 7j, and then vector B is giving us 3i plus 5j. So the angle between vector A and vector B, we need to find the dot product, which is vector A dot vector B equals magnitude of vector A times magnitude of vector B equals the angle between them, theta. So let's find vector A dot vector B. This is equal to 4i plus 7j dot 3i plus 5j. This is equal to 4 times 3. Let me write it well. This is equal to 4.3 plus the j part is 7.5. So 4 times 3 is 12 plus 7 times 5 is 35. 12 plus 35 is equal to, now let's find the magnitude of vector A. This is equal to square root of 4 squared plus 7 squared, and 4 squared is 16, and 7 squared is 49. So magnitude of vector A is equal to square root of 16 plus 49 is square root of 65. And the magnitude of vector B, this is equal to square root of vector B is 3i plus 5j. So square root of 3 squared plus 5 squared. And this is equal to square root of 9 plus 25. And this is equal to 9 plus 25 is 34. So it's square root of 34. So we know the magnitude of A, magnitude of B. Let's make cos theta the subject. So cos theta is equal to vector A dot vector B divided by magnitude of A times magnitude of B. And this is equal to vector A dot vector B is equal to 47 divided by magnitude of A, which is square root of 65, and times magnitude of B, which is square root of 34. So cos theta is equal to 0.9998. So theta is equal to cos inverse of 0.9998, and theta is equal to 1.14 degrees. The position vectors vector m, vector n, vector r of the 3 points M and R respectively are given by vector m equals I plus j, vector n equals 2i plus 3j, vector r equals minus 3i plus 2j. Find I, the column vector form, the unit vectors parallel to Mn and Mr. Then I correct to the nearest degree, the angle between Mr and Mn. So, vector m in terms of column vector is I plus j, which is 1, 1. And then vector n in terms of column vector is 2i plus 3j, which is 2, 3. And then vector r in terms of column vector is minus 3i plus 2j. So Mn is vector n minus vector m. And this is equal to position vector n is 2, 3 minus position vector m 1, 1. So this is equal to 2 minus 1 is 1 and 3 minus 1 is 2. So vector Mn equals I plus 2j. Then let's find vector Mr. This is equal to position vector r minus position vector m. And this is equal to position vector r is minus 3, 2. And minus position vector m, which is 1, 1. And this is equal to 3 minus 1. Minus 3 minus 1 is minus 4. And then 2 minus 1 is 1. And therefore vector Mr equals minus 4i plus j. So the question says we should find the unit vectors parallel to Mn and Mr. So it means that we should find the unit vector of Mn and the unit vector of Mr. Remember, unit vector is equal to vector over magnitude. So we need to find the magnitude of Mn, vector Mn, and that is equal to square root of 1 squared plus 2 squared. And this is equal to 1 squared is 1 plus 2 squared is 4. So that is square root of 5. So the unit vector of Mn, so unit, let me write it well. Unit vector parallel to Mn is equal to vector over magnitude. And the vector of Mn is I plus 2j divided by root 5. So we can multiply through by root 5 over root 5. And this is equal to root 5 over 5 I plus 2j. Let's also find the magnitude of Mr. This is equal to square root of minus 4 squared plus 1 squared. Minus 4 squared is 16. Then plus 1 squared is 1, so it's square root of 17. Okay. And then we also found the magnitude of vector Mn as root 17. So unit vector parallel to vector Mn is equal to the vector which is minus 4I plus j divided by the magnitude which is root 17. So you can rationalize by multiplying by root 17 over root 17. So this is equal to root 17 over 17 times minus 4I plus j. So this is the unit vector parallel to Mn. Then the last part of the question says we should find the angle between MR, vector MR and vector Mn. Please, I made a mistake. This is vector MR. So this is the unit vector parallel to MR. This is a mistake. So let me cancel it and write it well. This is vector MR and this is vector MR. So in fact, we know that vector Mn, so please pardon me, this is magnitude of MR. Vector Mn equals I plus j plus 2j. So vector MR is minus 4I plus j and vector Mn is I plus 2j. So let's find the dot product, which is vector Mn dot vector MR, and that is equal to Mn is I plus 2j dot MR is minus 4I plus j. So this is equal to, in one bracket, 1 times minus 4, then plus 2 times 1. So this is equal to minus 4 plus 2. That is equal to minus 2. And then we know that magnitude of MR is root 17 and magnitude of Mn is equal to square root of 5. So we also know that vector Mn dot vector MR is equal to magnitude of vector Mn times the magnitude of vector MR cos the angle between Mn and MR, which is theta. So let's make cos theta the subject. Cos theta is equal to vector Mn dot vector MR divided by magnitude of vector Mn times the magnitude of vector MR. So cos theta is equal to the dot product of Mn and MR is minus 2 divided by the magnitude of Mn is square root of 5 times magnitude of MR square root of 17. So cos theta is equal to minus 2 divided by square root of 5 times square root of 17 is 9.2195. So let me continue from here. Cos theta is equal to minus 2 divided by 9.2195 is minus 2 cos theta is equal to minus 2 divided by 9.2195 equals minus 0.2169. So theta is equal to cos inverse of minus 0.2169. So theta is equal to 102.5 degrees. However, the question says we should find correct to the nearest degree. So the nearest degree will be theta equals 103 degrees.